Right now we'll be looking at the reverse delete algorithm, and the reverse delete algorithm is really simple. In the previous videos we've treated the Kruskals algorithm and the Prim's algorithm, all for finding MSTs. For this reverse delete algorithm, we start from the graph, the whole graph. So just like I've drawn the graph right now, we start from this graph. So what we do is we find the greatest edge of the edge with the greatest cost. That's what I mean by the greatest edge. So we find the costliest edge, and we are going to repeatedly remove the costliest edge that does not disconnect the remaining graph, or that is part of some cycle. So if the costliest edge or the next costliest edge is part of a cycle, you remove it. That's what we're trying to say. If it does not disconnect the graph, that's what it means to be a cycle. You remove it. So let's draw an example from this graph. So what's the costliest? 10. And if I remove 10, that's from A to B, it does not disconnect this graph. Or yeah, so yeah, we remove it. So the next is 9. And does 9 disconnect the graph? No, so we remove it. The next is 8. Let's see. If I remove 8, it's going to disconnect A, right? 8 goes from A to D. So if I remove it, it's going to disconnect A. So I will not remove it. Okay, let's check again. 7. Yes, I could remove 7. It would not disconnect the graph. I could also remove 6. It would not disconnect the graph. The next would be 5. But if I do remove it, it has disconnected E. So I would not remove it. The next would be 4. But if I remove 4, it would disconnect. Take a look. It has disconnected the graph. So we will not remove 4. The next would be 3. Let's see. 3 did not disconnect the graph. So the next would be 2. Let's see. If we remove 2, let's see. 2 does not form a cycle. So we will not remove it. So we have 2. We have 1. 1 would disconnect B. So yeah, that's all. This is our MST. There is no other edge that we would remove that will not disconnect the graph. Or we can also say it this way: there is no other edge that we will remove from this tree as it is that is part of some cycle. We don't have any cycles here. So this is our MSTs. And again, the cost of this MST is exactly the same cost you would have gotten if you had used the Kruskals algorithm or the Prim's algorithm. For the reverse delete algorithm, we prove it using a cycle property, and we'll be discussing the cycle property in the very next video. I'll see you on the next one. And if you liked this video, please remember to subscribe. It's totally free. I'll see you in the next one.